in the sense that if the majority of data up there were SQLizable, if that's a new word, then Facebook and Twitter and all the rest would be embracing it. So what I'm trying to understand is to what extent is the exabytes, petabytes of data out there going to be SQLizable? And I think my impression is it's going to be the minority of that data, 10, 20%, I don't know what. So what's your sense of that in terms of the value proposition of SQLizing data in the non-SQL world, if that makes sense?
So the question, if you take all the data out there that's not already in a relational database, what fraction of it is going to benefit from all these efforts to provide support for that data viewed as relations even when stored on Hadoop?
Correct.
Okay. Priyank, then down the table.
So I cannot make a forward-looking statement saying 10 years from now, 20% of data is only related.
Just today.
But I can make an observation of what we've been seeing with the data sets that are associated with unstructured data. Almost a lot of the data sets that people are interested in analyzing have what we call an evolving schema, where schema exists. As was pointed out earlier, schema is there. It's not that it's fully relational or fully unstructured. It's somewhere in the middle, and it evolves very quickly. It may be that in the next month, in the data feed, we suddenly have 2 more feeds which are changing very quickly. And so systems which deal with this evolving schema are important whether they use SQL or not from now.
And that's actually a good point, because that's exactly the design center for Apache Drill is the evolving schemas, right? It's that JSON file that I'm not going to go and define in a different system what that schema is and make sure it's always up to date, because tomorrow, the JSON records are, they could have another field added to them, right? So I just want to grab that file and I want to run SQL query on it, and that's why we designed Apache Drill to be able to do that without predefining that schema. So that's really, we see Drill as bringing SQL to this world of data that's kind of semi-relational, if you will. Does not have a fixed schema that never changes.
Alan, you want to comment?
Well, I think I want to go along with what Priyank was saying, but I would also say it's not just that it's not an attempt to legitimate SQL in these things. It's that as Hadoop grows its user base, SQL is the English of the data world, right? Everybody knows SQL. And Hadoop grew up in a world with experts that could program in Java and get paid to do that and frankly like to do that, and weren't particularly motivated to make it easier to use, right? As it spreads out, that becomes less and less true. So it's not about legitimating SQL, it's about opening up the power of Hadoop to more and more people. But I think, I'd like to echo what the other people have said, is that I'd actually like to cast a little differently, but I think it's the same idea. There isn't really unstructured data, right? We call it unstructured, but all data has structure, or it's just crap. Right? It may not be relationally structured, it may not fit well in your database, but that doesn't mean it doesn't have structure and meaning, right? And so I think SQL can still be a very good tool for getting at some of that. And obviously all these other tools are going to be useful too, but I think the other tools are more useful when it comes to different paradigms more than different types of data. Right? I think it's more about, are you trying to do graph processing or ETL or analytics? Right?
Thank you.
Thank you.
Hi, my name is Guru Eleshwaram. So basically, I have a very simple question. Can somebody talk about the performance of SQL on Hadoop? The reason being, I'm asking a straight question from my customer. They have a SQL implementation today that has a lot of limitations. So one of them happened to be it doesn't scale in terms of storage, and they cannot budget the storage. They cannot come up with a budget for the storage. The third piece is when they do the search, it takes days. So they think that, or they ask us to move their data to the Hadoop. But now that I just came to know that SQL is going to run on the Hadoop, can you comment on how it can impact the performance? Does it degrade or does it improve or whatever? So I just wanted to hear from you what you're talking about.
So I'm going to summarize that as, can you provide pointers to resources on benchmarking of SQL on data stored in Hadoop. Is that a fair summary?
Yeah, something like that.
There has been a fair amount of work on this, so hopefully people can give you pointers.
So I can, if you look at some of the blogs that we put out around Impala comparing it to the latest generation of Hive and just comparing it to the numbers that you're able to achieve, the more important thing is actually getting those responses back in seconds. And there's blogs that we have. In terms of what to go and consider with this, and one of the design considerations that we had very early into the talk, was not just how well we do with a query, but how well we do under concurrency, and can continue to achieve linear scale. Right? Add more machines, you get more concurrency, you get more throughput, and you can maintain and toggle the amount of latency you get with that. And you'll see some that's available now and some that we have, but have not actually gotten published some of those things. One of the interesting things and one of the challenges here is the differences between the open source vendors versus the proprietary vendors. Proprietary technology you actually can't. You can't use that technology until you've paid them money, and at that point you're sort of locked in. And most of them have clauses that prevent, in fact, the proprietary vendors at the table have clauses that prevent us from actually publishing numbers. We actually have some great numbers that if my colleagues at the table were going to change their licenses, I'd be more than happy to go and publish some very
Interestingly, this is something that is worth pursuing further, because I know organizations like the TTC are interested in this space and what does it mean to define benchmark. So even if you don't agree on standards, having some level playing field for comparisons will be good for all of us. This is something we should talk about.
Some of the challenges are different for.
So maybe one of the things I would suggest is those of you who have numbers to share, maybe just on whatever you have done, send me pointers and we'll make them available so folks like Guru can look up some stuff.
Okay, if you don't mind, I'll just have a follow-on quick question. So do you guys have guidelines how to move the stuff from the legacy SQL implementation to whatever we are talking about here? So is it listed on your website and things like that? Can we go and check it out, or?
Sure. I mean, there's a few different options in Hadoop on how to move data between Hadoop and other systems like relational databases. There's one option is that there's an open source tool that's part of all those streams. It's called Apache Scoop.
Yeah,
That's a tool that does it. I think one of the things you have with MapR, we provide a standard POSIX storage layer which lets you mount the cluster, and you can use the standard tools. If you're exporting from Teradata or any other system, just use the standard database tools to export to a file directly into the cluster.
And some systems like to just run a SQL query, as long as you mount the HDFS file system and make it like a Hawk, take it everything to the point down.
Thank you.
Next, yeah, please.
So one of the things too, I mean, I'd be happy to work with you as well in terms of the EDW rationalization play. We have a lot of customers trying to move different systems off. So we have things that I can work with, I can chat with you afterwards. Another company to consider is not just on moving the data, it's figuring out which things can actually run in these systems, what are your expectations in terms of performance from that, and optimizing the right system for the right things. Keep the high value data in your high value, in the expensive systems. There's a company called Affluent, who's a partner of ours, I believe probably partners with some other folks here, that they will actually analyze some of the logs that are coming out of these systems and help you through that process. But in general, we've had a lot of experience with that, so I'd be happy to chat with you afterwards and give you some comments on how to make that work.
Thank you.
Next one.
My question is with the ISO to JDB connection and more SQL context. Now more and more tools and more users who may not have a Hadoop background, who don't know how Hadoop works, will be executing a lot of queries against Hive or others again. Are we like opening the thread case before we actually preparing for it? Do we have like resource management and other things in place before opening the thread case?
Sorry, can someone paraphrase the question?
So I think the question is, can we handle the workload, right? Do we have the tools necessary if you've got 100 users on your cluster and they're all throwing SQL queries at it? Can the cluster manager is going to fall over?
Yeah, especially like, they don't know the concept of Hadoop or MapReduce. Like, they're coming from a traditional SQL point of view. Just like
they're not writing queries with MapReduce in mind, is what you're saying. So, all right, I think it's fair enough. Definitely the tools can handle it. I mean, Hadoop has, there's lots of installations with thousands of machines and hundreds or thousands of users. So concurrency is certainly not a problem with Hadoop. I think it is